All right. So what was the homework assignment? You're supposed to do what?
To count
The
numbers
counter.
between 1 to millions.
Okay.
That's like
So let's start right there. So count the number of numbers.
that are easily divisible
That's
by 9, 12,
a million.
7.
Did we already talk about I plus plus? Or just
no,
I equals
no.
I plus 1? Okay. All right, that's fine. All right, then you're counting the number of numbers. All right, that are evenly divisible by what?
By 9.
9, 13, 27, or 81.
Okay, so if I mod, you said 9 is equal to 0, or I mod, what was the next one? 13 is equal to 0, or I mod, what was the next one?
27.
27 is equal to 0, or I mod
81.
81 is equal to 0. If any of that is true, count is equal to count plus 1. What should the answer be?
147,090.
I equal 1.
Oh, it starts off at 1? That one? 1 to a million?
Yes.
And if it's evenly divisible by 9 or 13 or 27 or 81?
Yeah.
That's the number?
Yeah.
All right, there's your answer. Make sense? Did you bring me Portillo's? You got a haircut. Did you bring me Portillo's? Next week for sure.
And then he's going to fix it next week.
All right, so that was the answer to the homework. Questions about that? All right, so then the other question was, you were complaining about something with Angel, right? Or I'm sorry, something with Solaris. Do. Write a 3 to 5 page paper. It's only 3 to 5 pages.
Dude, that's a lot when you have other classes that have like 5-page papers.
This is grad school. You're supposed to be tormented, right? Really?
Were you?
I finished my PhD when I was 21. Of course, I was tormented.
Depends on the question.
I skipped out of my whole college life. Write a 3 to 5 page paper describing the use of Java in the first Intel version of Solaris operating system by Sun Microsystems. Paper should contain at least topics related to performance, security, hardware compatibility, and user experience. Okay, so what did we find? So, first version, we got stuff?
Huh?
10.
All right, so
And that was 2005.
all right, so 2005-ish, Solaris 10. They came out with an Intel version of Solaris. Before that, Solaris ran on what platforms? The Sun Spark.
Spark, yeah.
Sun Spark processor. That was their own equipment. So for a long time, Sun Microsystems, they wrote hardware and the software for their hardware, much like Apple. Pretty similar to that. But then people saw the writing on the wall. There wasn't as many You weren't going to Best Buy buying a Spark station, and they were very expensive. They probably still are. If you go on to eBay today and you look up for a Sun Spark Workstation 5 or something like that, you'll probably find that they're still many, $2,000-$3,000 for something that is nowhere near as much power as like an iPhone has today. So they were mainly server class type machines. So you were supposed to talk about performance. So let's talk about that first. So Solaris 10, was it completely written in Java?
What I read? No.
Okay.
C, C++.
Okay, so the operating system was an Intel-based operating system, but it used lots of Java stuff within it, right? What specific Java technology was heavily used in Solaris 10?
I like desktop. Like, how can they use appeal with the desktop, like Windows?
Well, they heavily leveraged a very specific Java technology inside of Solaris 10.
LXM or something called elements for top. What's it called?
Java Applets. Java Applets was something that was later became known as WebStart. Java's WebStart technology. So throughout Solaris, anytime that you'd see a widget or something like that on the screen, it was Java applet based. So those were all running as Java. Now, what does that mean in terms of performance? So as soon as we bring, so there's a couple different levels here. First of all, we bring an operating system that's been running on the Spark 64-bit architecture for years and years and years. Now all of a sudden we jump it onto Intel. So it's a brand new rewrite. This is not code that's been tested for a decade. This is code that has just come out now. So on one hand, it was brand new. It was as if it was a brand new operating system. What about cost? Was it? How much was Solaris 10?
Free.
It was free. How much was Solaris 9? Expensive. So that's where the correct answer is expensive. So it was at this point in time that Sun kind of switched gears. They went from offering very expensive hardware and software solutions, mainly to universities and corporate enterprise type thing, where places were running Sun machines as servers. When I was at Western Illinois University, our whole backbone to the university, our network, was all our network and our servers were all Sun stuff. So we had these giant cubes that were Sun Spark stations. They were servers, and they got really hot. You could like cook eggs on top of them, no problem. So in any case, Western, I don't remember the exact numbers, but paid a lot of money to Sun Microsystems per year for their support contracts. So that's how Sun made their money for a very, very long time. So now they turned the corner. Everything was moving towards Intel at this time, and they turned the corner to decide, you know what? We want to get in on that market. So there was a movement with Solaris where they wanted to start capturing the normal consumer, not just the server enterprise class people. What do you think led that movement? The advent of what other operating system made it cool to be a Unix type operating system on PCs, on Intel-based architecture? How many of you have ever used Linux? Okay, so it seems like you hear less about Linux today than you did maybe about 7 or 8 years ago. But Linux is still, you're a cool geek if you run Linux. And back then, Linux was the cool geek thing to do. So most people ran Windows, and then if you were a geek, you also had a Linux box. I would say at that point in time, most geeks did not run Macs. Macs weren't what the cool kids were doing like they are today. So anyways, Sun Microsystems looked at the rise of Linux and their belief that, oh, wait a minute, a Unix-based operating system is maybe going to end up taking over the world. supplanting Microsoft Windows on the desktop. But Sun Microsystems, being who they are, a proprietary company, has been writing server class stuff for years and years and years. They looked at Linux and saw a major weakness. The fact that it was open source, they felt led to some performance issues or stability issues or security issues. So their opinion was that while Linux might be a nice toy type operating system, it would never be appropriate in the server space. But Sun Microsystems has been in the server space forever. So if they came out with a solution, they might be able to take over the server space. The big catch being Linux is free. So in order for Sun Microsystems to compete in that space, they also needed to be free. So that's where they took advantage of this rewrite to make it for Intel, but also embed Java heavily into the operating system, which negatively impacted its performance. So day one, Solaris 10 was nowhere near as fast as comparable Linux machines because there was so much bloat with the operating system running with all these Java widgets going that it was only even usable if you did not run a windowing manager. You didn't have a graphic user interface. If you just ran from the command line, that would have all the Java stuff turned off. So performance would have been bad on two different fronts. One front was that they were using Java for all their on-screen widgets, which is a performance issue. The other problem was their windowing manager was based off of a project called GNOME, G-N-O-M-E. Back then, there was kind of two big competing companies that were two big competing groups. They weren't companies that were making windowing systems for Unix-based operating systems like Linux. And GNOME was one of them. And porting GNOME over to Solaris was not as easy as they expected it to be. So Solaris for Intel ended up kind of being a pretty big flop. They rushed it to market. It needed to get out because they thought they had an opportunity to take over the server market in the free space. And you're like, well, why do we want to take over the server market in the free space? Well, once you have the market, then you could all of a sudden start selling them products for their servers. And the products maybe then cost money. So performance was a problem right off the bat because of Java. And also because of poorly written stuff. What about security? Security good, bad? On paper, the idea should be that security was going to be good because Sun had been doing this for years and years and years. The problem is all the security stuff that they had written for years and years and years for the Spark version of their operating system had to be rewritten for the Intel version of their operating system. Having said that, security wasn't necessarily considered to be a problem with Solaris 10. Is that because security wasn't bad, or is it because nobody used it? Who knows? But I think it's reasonable to say that security was at least decent for Solaris 10 in general. Now, what about Java? Does Java does Java help with the security of something or hurt the security of something? Help. Why? Why would Java help with the security of something? I'll start off by saying I agree with you.
Because we can't access other files on a computer.
Okay, why?
Because of the Applets.
And that's something specific about Java technology.
I mean, there is something called simple authentication and security layout. Provides developer for application shared library with interface or Java.
Okay.
That's what they have in this version.
But specifically, why would Java benefit, just in the big scheme of things, why would Java benefit security?
Because deal with the safe file.
Sign for certificates.
What's the benefit of Java? forget about Solaris for a second. Tell me about Java.
Independent platform.
Okay, platform independent. How is it platform independent?
Yeah, you can run it anywhere.
Okay, that's what it means, but how? How do they accomplish that?
Virtual machine.
Through a virtual machine.
Yeah.
How many of you have ever run a virtual machine on one of your computers? Like maybe at work or something like that, you're running a different version of Windows, or on a Mac, you're running Windows in a virtual machine. If you get a virus in that virtual machine, so on a Mac, let's say you're running Windows in a virtual machine on your Mac using VMware or Fusion or something like that, and you get a virus in that install of Windows. Is your Mac destroyed?
No,
Why?
because it's just destroyed the Windows. It's not going because it just deal with the file, that machines.
Yeah, the virtual machine is
Yeah,
just a
it's
program.
machines, yeah.
It's just a program, and you could just delete it,
Yeah.
or you could roll it back. So maybe what you do is you back up that file to a point where it didn't have viruses. You know, maybe right after you install it, you say, okay, well, I have all my software configured on here. Everything's the way I want it. There's no viruses. Back it up. Now you can use the thing risk-free, because if you ever have problems, especially if you use cloud storage, use Dropbox or something like that, if you ever have problems, you can just delete that virtual machine, restore the old one that didn't have a virus, pick up where you left off. Keep going. Why? Because virtual machines exist at a level above the actual hardware. You're protected. The hardware itself, the file system itself is protected. So from a security perspective, things that are running Java are not easy entry points into getting to the underlying files. Why? Because in order to get to those underlying files, you need to go through the virtualization of the Java virtual machine. And sometimes there are not direct connections. So for instance, getting to the actual file system on your hard drive through the Java virtual machine is not, in some cases, isn't even possible. They're not connected that way. Java creates its own virtual file system to make things work. So you could make the argument that Java actually makes a server more secure, depending on which areas of the server the Java is used. So these first 2 points are actually kind of contradictory points. Java probably hurts the performance of a server because it's a virtual machine. Java probably helps the security of the server because it's a virtual machine. So those are contradictory points. So maybe the thing you should have taken out of this is performance sucks, security is still pretty good.
Point taken.
Okay. What about hardware compatibility?
It's not that big issue.
Well, there's two levels here.
Okay, about the processors and the hardware.
Yep. So generally speaking, hardware compatibility of Solaris 10 versus Solaris 9 was what?
The Intel.
Was it better?
Yes,
Why?
because when they use 86 for yes, as the Java is independent platform, is not going to affect the processor. The Java virtual machines it can deal with that.
If we go back to Solaris 9, which was their last version of the operating system that ran on their Spark chips, only on their Spark chips, what hardware did they have to support? We mentioned this a few minutes ago.
Their processor.
Their own crap.
Yeah.
Sun Microsystems was a lot like Apple. They wrote software for their own hardware. So they only had to support their own junk. Their own video cards, their own hard drives, their own everything. Okay? As soon as they dove into the Intel world, the number of people who can run Solaris on their machine went huge. Grew a lot. Because now you didn't have to have an expensive Sun server or workstation in order to run Solaris. You could have a budget pleaser Packard Bell that you bought at Walmart. So hardware compatibility probably went way up. The number of pieces of hardware that were supported went way up. Otherwise, this wouldn't have worked, right? Okay, what about user experience?
I mean,
Huh?
More like user friendly.
Compared to Solaris 9?
yes,
Okay.
Because they use them, especially use them with the Windows experience with the Solaris 10.
Okay.
They're familiar with the desktop with the Windows.
Well, and that was, the way I always phrase it, the gateway drug to that was what? It was GNOME.
Yeah.
Okay,
exactly.
so historically, Sun Microsystems, on their earlier versions of Solaris, they had their own windowing environment that they created. And it was fine. It was a graphical user interface, but it was not something that you would want grandma using. Now, GNOME was a project that was very much supported in the Linux community. Now, I might still argue it's not something you'd want grandma using, but the reality is that GNOME was designed to be competitive with the Windows graphical user interface. You know, it kind of had that idea of the start button, and back then, GNOME, the start button was this little footprint, this little GNOME footprint guy.
Yeah, I know.
So it was bottom left-hand corner, same place where the start menu is, all that crap. So the idea is they made a pretty big leap forward in their graphic user interface simply because they used something that other people were working on rather than their old proprietary system. Okay, so the user experience probably went way up. Outside of the sluggishness that you may have had from performance. The Solaris 10 definitely felt sluggish. All right, anything else you kind of found in there? And there's
About the user experience, there is like the developer when they use the Solaris 10, it's kind of like easy for them sometimes. They reduce the complexity, the complexity for the version 9, and it was easy for them when they're going to use like 10 version 10.
probably the biggest thing was installing new software. Installing new software on Solaris 10, they used a tool called apt-get, which allowed you to do it, where previously you had to use Sun's command line installer tool. It was more difficult. Okay, so those are some high points you could have talked about. I don't know. It seems like there should be. I think there was plenty of information out there. I spent like 30 seconds looking. I found a couple things.
Because
That's 'cause
this
you
come
already
from
knew
your
it.
experience.
I just did a Google search.
No, because this comes from your experience. Okay. When I'm looking for bare films, for example, I went to Oracle's website.
Yep.
Okay. It doesn't make sense. They are going to say, "Oh, it's bad with the film." They'll say, "Okay, it's good with the film." Because
Well, right, but keep in mind this predated Oracle.
yeah, but how can I get the information or get the person who has experience about this stuff in 2005, or who has experience like you before 2005, and they can compare between this?
Well, because the internet existed back then, and plenty of people talked about it.
Yeah, but how can I believe the internet for this? I couldn't find anyone who can talk about this experience like what you did.
Well, if I did it, somebody else had to do it on the internet. Nobody, the whole internet, nothing.
Yeah, believe me. If somebody, you can disagree with what I
Well,
said, yeah.
but you said you finished a paper, right?
I finished it, okay. All the three things, security, hardware, yes. It's the same what you said. But performance, no. I said no, it's high performance. That's what the Oracle said in their website.
I think you could make an argument for high performance. I mean, you would have to make the correct argument, but I think you could make that argument.
That's what the Oracle said about
Here, in fact, I'll make the argument for higher performance. The big reason they jumped from Spark to Intel is because Spark chips were sputtering; they weren't getting any faster, and Intel kept growing, getting faster and faster in chips. So the idea might be that, instantly you have your Solaris operating system running on a much higher performance hardware, so everything would be higher in performance than it was on the previous version. Even if it was sluggish because of Java, it was sluggish relative to other things running on that same newer hardware. So you could make the argument that it was higher performance compared to Solaris 9 running on Spark. I think that's fair.
I mean, they are talking about that virtual machine, and they use GMX, the protocols to management interface for that application. That's what make version 10 more high performance.
Well, so it sounds like you found a bunch of crap.
Yeah, But I want to make sure this all this you can agree with me. That's what
Well, no, I won't. I'll just mark it all wrong.
I'm. Okay.
But the point is that you found it. Ay, ay, ay. All right. So, what was the last thing we talked about last time?
It was the do while loop.
Okay, and then I kind of gave you your assignment.
Yep.
All right.
Oh, never mind. Yeah. Do while.
Okay, so let me show you a couple of things here. Let's say I have a character named C, and I start that off at A. That's the character A. Remind me, what's a char? Guarantee that's not what the slide said. What's a char?
Sign.
Oh, what?
Unsigned.
How big?
16.
16-bit unsigned integer. So what's the range of values that hold that a char like C can hold?
0 through 65,535.
Okay. So these guys, a char can hold 16-bit unsigned integers. Right? Okay. Yet, what did I just stick in there? I stuck in there a char. Okay. How do we identify this guy as a char? It's surrounded by these single quotes. That's what makes a char a char. Okay. So now, let's say I go system.out.println C. What will the output of this program be?
One to be C and one to be A.
Okay, so this one will print out the contents of C, which is A. This one will print out a C. How does it know that this guy's a variable and this guy's not?
There's no single quote.
Okay, the single quotes here mark this guy as being something that's not a variable. Whereas since we don't see the single quotes or a couple other things that can mark it as something else, we notice that this guy is a variable. So since it's a variable, its name is C, we need to resolve that variable. That means get the value contained within that variable. So we look in the most local scope, which is any local variables here, and we define a variable named C of type char and set it equal to A. So this should print out an A, and then it should print out a C. All right, but now I told you that chars hold 16-bit unsigned integers. Right there. Okay, yet I printed out that char and it displayed an A. What happens if I say int I is equal to C?
Then I will be
And I print out I.
Wrong. Okay. So ASCII code.
Interesting.
97.
What's C?
A.
The ASCII code 97.
What's C?
Kappa.
C is a variable, right? A lot of the exercise, so just fair warning, I'll still keep tricking you. It's going to be funny. When I ask stuff like that, almost always, I'm trying to get you to think about it in its most simple terms and then unwind it from there. What is C? C is a variable. It's a variable of type char. What do chars hold? Chars hold unsigned 16-bit integers. Okay? When I use C, it resolves to its value. Its value is what? An unsigned 16-bit integer. But when I print it, it printed out an A as opposed to a 97. Why?
The Unicode C or ASCII.
I created another variable called D, type char, set equal to 97. What's that going to print out?
97.
No.
A.
C. A.
Well, hold on. Didn't I tell you that chars are surrounded by single quotes?
Mm-hmm.
Where's my single quotes?
You didn't need
No, this is the value of A. And
Yeah, but chars are single quotes.
them. But it's also
this is
unsigned
the address
integers.
of the value in Unicode.
Well, can I do this? This doesn't seem to be consistent at all, does it? I'm telling you chars are represented with a single quote followed by a single character followed by a single quote. So there's a char. I'm storing it inside of a variable named C of type char. What's C? C is a variable of type char. And we would say that that guy holds a char, correct? Well, I'm taking that char, I'm putting it inside of what?
But int.
A variable called I. That's of type integer. Well, what's an integer?
It is a signed whole number.
It's a signed 32-bit whole number, right? What's the range of values that fit inside of an int?
2 billion, negative 2 billion to positive.
Negative 2 billion to positive 2 billion. Plus or minus 2 to the 31st power.
Yes.
Okay. What's the range of values that could fit inside of a char?
0 to 65,000.
0 to 65,535. So, can I store the number 300 inside of an int? Can I store the number 300 inside of a char?
Yes.
So that's why that worked. What is C? C right here is a variable that holds a value. It's a variable of type char. What kind of value does it hold? It holds some char. What's a char? A char is a 16-bit unsigned integer. So I'm taking that number and I'm storing it inside of this variable. What's this?
That
This
is
is char.
2-bit.
That's a char. What's a char?
A char is a 16-bit unsigned.
16-bit signed integer. Now, I'm not from this neighborhood, but I've never seen a 16-bit signed integer look like that. That looks like something else, right? But clearly, I was able to put it into a variable called j of type int, which says that this guy, so when I asked you what this is and you said it is a char, that's correct. That guy is a char. But then I followed up with, what's a char? It's a 16-bit unsigned integer. Well, that might not look like an integer to us, but sometimes looks can be deceiving, right? Okay, so, as we saw up here, I took that char and put it inside of this variable capable of holding a char. Can I do, well here, let's do it on this one. So we just saw that I was able to create a char D and set equal to 97, right? Can I set equal to -5?
No, because it's got to be 0 to
0 to 65,535. Make sense? All right, so any questions about this? I'm taking an unsigned integer, storing it inside of a variable to hold unsigned integers. I'm taking an unsigned integer, storing it inside of a variable capable of holding signed and positive and negative integers. So I can hold any positive number inside of an int as long as it's less than 2 billion. Taken a char, I would call that a char literal, and I'm storing that inside of an integer, which is capable of holding -2 billion to +2 billion, but we happen to know that all char literals will be between 0 and 65,535. Now I'm taking a number, 97, which is a number between 0 and 65,535, so it's fair to say that as it stands, that's an unsigned number, right? And it certainly falls into the range of a unsigned 16-bit number. And I'm putting it inside of a variable named D, capable of holding 16-bit unsigned integers. No surprise it works, right? But when I print them out, when I print out C, it showed me an A. Right? When I printed out I, it showed me a 97. Why did it show me a 97 and not an A?
Because that's out of holding.
Because this guy is of type int. This guy is of type char. If something is of type char, the println method knows that it needs to go and do the lookup. It knows that, okay, I see a 97, but that guy is stored inside of a special container for holding chars. Therefore, I need to go and actually look it up on the Unicode table and get the character that he's talking about that is associated with the 97. That makes sense? But here, since I is an integer, it's just going to print out the number. What about D? D is a char. It's going to do the mapping. Even though I stored what looks to us as a number. That looks to us like a non-char. Correct? All right. What's J? J is an int. Prints out the 97. So it's an int, so it's going to print out a number.
Yeah, can we use data type float instead of integer? Float I equal to C, what will be the result?
Let's do double. I think it'll be 97.0.
And for char D equal to, can we assign 97 in commas?
That?
Yeah, 97.0.
Something like that.
Because it's a character.
Because the integers don't know how to hold decimal point numbers. This is a legal value to pass to an int. Where a char, we know a char is basically an int.
Yes.
It's an unsigned 16-bit integer. And anything that's an integer type does not comprehend things that are decimal point followed by stuff. Those are illegal characters inside of integers.
Yeah, can we assign minus A for a character minus A minus B? Is it possible?
Not in a not in a char.
What do you mean minus?
A negative.
Like you want me to say that?
Yeah,
Well,
It's illegal.
what is that? That doesn't make sense.
no, like before.
And that doesn't make sense.
Nope.
That's out of the range. Range has to be 0 to 65,535. And now that's negative 97. So these are specialty containers that can only hold certain kinds of values. What can I put inside of a char variable? I could put any number between 0 and 65,535. And I can represent those numbers as numbers. Or if I prefer, I can use char literals like this, which I know map to numbers. In fact, I know are actually represented as numbers, and the mapping only occurs when I display. Okay, this makes sense to everybody? All right. What's going to happen if I add 1 to each of these?
B, I, 98, D, B, 98.
They're all 98 now. Why?
Because you added an integer.
Because there's operations.
What does C resolve to there?
97.
C is a 97, correct?
Yeah.
When I was just printing out C, it recognized it was a char.
Right.
But now it's 97 plus 1, which is a 98. That's an int. So I printed it out as an int.
It's going to ignore the char, the type char.
But what if I do this?
No B.
It's giving it an error.
Well, I thought that saying C is just like saying I could store it in an int up here, right?
Mhm.
Can I say C is equal to,
Oh, because you have C as being a char variable, so
Well,
therefore it won't.
right
Store
here, I
it.
said char D is equal to 97.
True, but it's reading. It didn't. I don't know. Never mind.
That seems to work. So I can do math up there that way.
True, but I don't like the one at the bottom.
What's I?
It's 97.
97. As soon as I changed it, as soon as I resolved it to a 97, it became what? A legal statement.
Yeah.
What will it print out right here, right now?
98.
What's C?
A.
C? No, B.
It'll print out B.
Yeah.
C is a char, so it'll do the mapping.
Interesting.
There's my B. So C started off as A, and then I completely overwrote it with what? 97 plus 1, which is a 98. Well, if A was a 97, B is a 98. What do you think C is?
98.
99.
99, so on and so forth. Okay, but why couldn't I say this? Why couldn't I say, here, let me do it this way. I'm going to say 97 there. Then I'll say I here.
No.
What is the difference between me saying 97 up there, I plus 1 down here, or just saying 97 down here? Why does one work and the other one doesn't?
Because you cannot use it until syntax.
What's I?
I is an integer. Well, variable.
Yes.
Holding a 32-bit
It's 52
integer.
bit.
That works though. That's the value of I,
True that.
right? So, true that. True that. Okay, so I holds 97. So when I type in I here and it resolves I, won't that become a 97?
It supposed to, but for some reason it don't like it.
I mean, this is the fun.
Why?
The size-
Why does that not work and this does work?
Because the size of memory, I mean, integers bigger than
Okay, tell me about that.
like if you bring eyes and you have like this size and you want to put it in a small size, it's not going to deal with this.
But we know I holds 97.
Yeah, because
Mhm.
C
The
is char.
computer is not, it doesn't know about that. It doesn't know about that.
Okay. We know. As humans, we can see, oh, we know that we only have a 97 up here in I. We know that, right?
Right.
But when I type in I right here, even though we can see above and know what the value of I is up here, keep in mind there could be 10,000 lines of code between those two lines, where we may have changed I 1,000 times. We happen to know as human beings because we can look at the whole program at once and see, oh, well, I is 97. But the compiler doesn't know that at this point. The compiler is going to look at this and say, okay, you're trying to store inside C whatever the current value of I is, which we will resolve at runtime. I gets resolved to its value at runtime, when the program's actually running, not
Combine.
at the compile time. So as of right now, our compiler does not know that I holds a 97. It knows that I holds what kind of value?
32-bit.
Some number between negative 2 billion and positive 2 billion. A large portion of which would put it outside of the realm that C can hold. Right? Because C can only hold 0 to 65,535. So it's correct for it to complain about I not working there. While it's reasonable for it to say, oh, 97 plus 1, that's cool. Because 98 is a number between 0 and 65,535. Make sense?
Yep.
Okay, so do we understand this stuff pretty well? What a quiz.
Absolutely
You just told me you understood this.
not. Mm-hmm. But still.
Kind of quiz. Doing programming or just that?
Oh, it's got to be programming. It's a programming class.
Well, why all the papers?
I could have you write a 3 to 5 page paper. Well, this is an IT program, and we can't trust you guys to be good programmers.
So you expect us to be good paper writers on a whole bunch of stuff that we don't even
Look, I
understand.
just work
when we
here.
read
Don't
it
yell
off
at me about
Wikipedia.
it. If it was up to me, we would just have programming assignments.
Yeah, I heard you change that up. Why?
We talked about that last time.
I need to repeat it.
We got we had our program got accredited by some accrediting body that requires us to have more theory in the classes. So now we have to have both application, which this stuff is, and theory, which the stupid papers are.
We could help you with topics.
No, but
Yes.
but the papers are good. It's good
No.
for you.
No, it's.
Actually, hold on. As an IT major, that particular paper was actually a very good topic. Because those are the types of things you're going to have to troubleshoot, and you're going to have to be able to think critically about how those different concepts play together to figure out whether something is better security or better performance or other things. 'Cause you're going to be running into old hardware all the time, or even modern hardware that has weird stuff installed on it.
Could we just have talked about that in class?
We did after I gave you the paper.
Yeah, that was pointless.
It's a new programming language for Google.
What?
I think Google. A new programming language. Just released 2 months ago. 3 months ago.
A new Google programming language?
Is it Google? I forgot. But they said it's going to be better than Java. It has the most.
Well, I mean,
good thing.
it could be, but I think at this point it would be that's kind of like,
Apple or
here's the punchline to a statement like that. It's kind of like Windows coming out with their Windows Mobile 8 and saying, oh, it's going to be better than Android or better than iPhone. Even if it has features that there's no way that it's going to take away market share from iPhone and Android because they hold 99% of the market.
And Windows need to
So it doesn't matter how good the language is. It's too far behind at this point. They would have to invent a new programming paradigm, something beyond object-oriented programming, I think, for it to catch up. Because right now, your big three are Java, C#, and Objective-C.
I'm VB.
Okay, I'll throw .NET in there. Okay, so everybody take out a piece of paper. And get your name on it.
You're really going to go through with this.
It's going to be hilarious.
You want our food number on there too?
Nope, just your name.
You know who we are.
Sure.
That's a good point. I was just curious. What's today? November 6th.
Guess I should say English alphabet. That'll be nice. Write the Java code necessary to display the entire English alphabet in lowercase to the screen. You must use less than 20 lines of code. So that kicks out system.out.println A, system.out.println B, system.out.println Z, because that's 26 lines of code. Get it?
Yes. Did you want us to show the
Just
methods?
prove it,
in
you can do this.
classes?
No, I don't care about that.
Okay.
Just write the, some lines of code that would accomplish this.
Comment?
What's up?
Comment?
Comment.
Comments. He wants to know if you would like comments
Sure.
in our code.
Yes, every line should be commented heavily. Okay, you got 30 seconds. I'll give you 5 minutes. Should be more than enough time. And you could use your notes if you'd like. The answer is not in your notes, but all the pieces to this, and all the things you need to solve this problem are in your notes. Between what we did near the end of class last time and what we did in this class so far today.
Can we try the codes in Java?
Sure. Remember, you only have 5 minutes. And I'm not assuming you're trying it in Java, so if you have a couple of little syntax errors, that's not a big deal. I'm looking for the
Logic.
competence, logical competence. One more minute. All right, make sure you got your name on them. Pass them this way. Oh man, I have to count the lines on this one. All right, who thinks they got it? One person?
I did it to display props,
Ah,
you didn't specify.
I'm cool with that.
I can give you mine then for that.
Yeah, and that I'm fine with that, I guess. I didn't specify.
I was laughing about it.
You always got to find loopholes. Let's see. Well, I haven't taught you C++ yet, so we have to. It's a little bit of a hack here.
Or you can use like C equals 97.
Did we?
Mentioned
mentioned
it.
it.
Yeah, mentioned.
Yeah, but I didn't actually show it to you, did I?
No.
No.
Okay. All right, we'll just do it on integers then. And then I'll show you the C. Then I'll show you the plus plus. 122. Yeah, you're not gonna be able to do it this way either.
I mean, you can do like that.
Well, yeah, but I haven't shown you how to do that. So this way you would have to say.
Keyword.
So that'll do it. I haven't shown you how to do that. It's less than or equal to.
Yes.
So that'll do all the letters.
You can use variable I as a type chart.
Right, but I haven't shown you how to do that.
Oh yeah.
So this works. So that works. That's what, 4 lines? The problem is I hadn't shown you C++. This is turning in now. Let's see. Would there have been an interesting? So her solution was what? System.out.println A B C D E F G H I J.
No, because I did like I did like int I equals 1, and then if I is greater than or equals 1 or no 0, then print it. So I made it a little bit more fancy.
I made it look a little programmy, a little more fancy than that. All right, so let's see. All right. Was it 122?
Yeah.
I'm not gonna be able to do that either.
Tried it. It was.
It was a trick question.
So you
All
should-
because of the plus plus.
You should totally throw out that quiz.
Or just give everybody zeros.
Absolutely not.
Well, now I'm interested. I want to determine the best way to solve this, given what you guys knew.
Nothing. I was sitting here more on my computer trying to figure it out than writing on the paper.
I don't know. You can do it. You either need to typecast or. All right. Well, so let me tell you about the plus pluses then.
So now that it counts.
What's up?
Nothing.
No, you didn't know it beforehand.
Right. So.
So we have an operator called plus plus. We have another operator called minus minus.
Really.
Yeah. So plus plus. So for instance, if I say I plus plus, that's the same thing as saying I is equal to I plus 1. Keeping in mind you can't say I plus 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 and think it's the same thing as adding 2. So I plus plus, or the plus plus operator, is like incrementing. It's the incrementing operator. Now what's interesting about this, so I'm going to create an int I is equal to 5. We'll say system.out.println I.
What was the other bullet point on it?
Then it'll say I plus plus. So first time, what's going to print out here?
5.
Then I'm adding 1 to I. What's going to print out here?
6.
Okay. 5 and 6. It's going to print out now.
6.
6?
6.
Okay. What about now?
5 and 6.
Uh,
No,
5. 5.
5 and 4.
5, 6.
5 and 6. Same thing.
Not for real.
So what's the difference between plus plus I and I plus plus? Well, we can show it real easily here.
The pluses are on different sides of the I.
What's going to print out here? Notice I've done my I plus plus inside the print statement, which I would never recommend anybody do.
6.
But it's legal to do this.
Still the
It'd be
same.
6.
5, 6? Okay, but it actually shows 5, 5.
Why?
What if I print out that?
5, 5,
5, 6.
5, 5, 6.
Next time, because it's after.
Now what if I change this and say plus plus I here?
5, 6.
5, 6, 6. So when the plus plus comes first, we do the increment first and then get the value. When the plus plus comes after, we get the value first, then we do the increment. That make sense? So plus plus I immediately increments I, storing the value back in I. Then we get the current value of I. If I say I plus plus, I immediately get the value of I. Then I increment I, storing the value back in I. So it all comes down to which value you have at the time you're using it. But like I said, I would call this bad programming practice to ever take advantage of the I plus plus or plus plus I thing. There are certain circumstances where it might make your life easier, but the reality is
Just
increment it on a separate line so it does exactly what you intend for it to do. Make sense?
yes, sir.
Because in this case, it doesn't matter if I say I plus plus or plus plus I, just doesn't matter. Okay? Similarly, where there's a minus minus, works the exact same way except it subtracts 1. That make sense?
Yep.
Okay, so that's for adding and subtracting 1. I guess while we're on that conversation, I'll tell you about the plus equals operator. So these are, I'm going to call them compound operators. We have several of these. We have plus equals, minus equals, times equals, divide equals, mod equals. So an example would be I plus equals 1 is the same thing as saying I is equal to I plus 1, which is the same thing as saying I plus plus, which is the same thing as saying plus plus I.
Still too much.
But the advantage with this is let's dump the plus pluses out of this I could say I plus equals 5. I plus equals 5 is the same thing as saying I is equal to I plus 5. So it saves us from having to write I the second time. Just a little shorthand. That's called a compound operator. The plus equals, minus equals, divide equals, times equals, all that crap. Make sense?
So you add in 1 to the 5. And that's gonna be.
These two lines are the same.
No, I was just making sure that that's what I'm. Oh, the.
Yeah, this is the same. I mean, so I plus equals 5 is the same thing as saying I is
Oh.
equal to I plus 5.
So it'd be 5 plus 5. Gotcha.
So whatever I was to begin with. So here, just test it out here. We'll say I is equal to 5 up here. I'll say I plus equals 10, let's say. And then I print out I. What should I be?
It'd be 15.
15. Make sense? Or it would be the equivalent to say I plus plus
Okay.
it's a dumb programming joke.
I get it. And I seriously thought you were special at first.
I am. Ask my wife. She says I'm a special needs husband.
She get SSI for you, from you too?
All right, so make sense? These compound operator things?
Yeah.
The last thing I'll show you, since it's related to this unsolvable quiz, is typecasting. We talked about types last time, right?
Mm-hmm.
So typecasting, the syntax for it is open parenthesis, type, closing parenthesis, before a value. So for example, I can take a integer 97 and I can force it to be a char by typecasting it to a char.
Can we assign negative values in typecasting? Character 97
Oh,
minus 97 and same value.
it would fail. It doesn't make sense.
Yeah, but
So typecasting has to make sense. So I mean, you're saying, could I say this? Can I try to turn minus 97 into a char? That's what you're asking if I can do, right?
yeah, but we can do in C.
It would fail.
Yeah, we
Because
can
it
do
has-
negative typecasting in C or C++. I'm not sure exactly what we can do.
No, but if you did it in C, it would fail.
It has to be between 0 and.
Because you don't have a number between 0 and 65,535. Java would catch the failure at compile time. Java kind of does some extra checking. C might not catch it until runtime, that you've put a horrific value inside of a char, but it would still break. I mean, typically you would say something like this. If you typecast something and you don't know what to expect the result to be, you probably shouldn't be doing it. So for instance, if you try to typecast negative 97 to a char, what do you expect the result to be? We know negative 97 is not a defined char, correct?
Yes.
So our expectation should be really, really, really low.
Hopefully.
Huh? Enter? Error. Yeah, that's my expectation. It's an error. Okay, so you probably wouldn't do this because it doesn't make sense, is the punchline there. We've seen some forced typecasting. So for instance, when I said int I is equal to A, that worked. There was an explicit, or implicit rather, typecast of int from that A. But we didn't need to do that because it treated it numerically as is. We didn't actually have to typecast it in order for it to work. But that's ultimately what happened. Make sense? So, as far as the code we just wrote goes, we could say for int I is equal to 97, I is less than or equal to 122 I plus plus, and we happen to know that we'll take I on a journey through all the Unicode values that we're interested in, and then we'll say system.out.println the char version of I, and that will print out the alphabet. So by telling println treat I as a char, it does the map lookup for us. That make sense? Similarly, we can increment chars. We could not add 1 to a C, but we could use the plus plus operator. The plus plus operator must be defined differently for chars than it is for ints. I could not add 1 to it. We saw that break, right?
Mm-hmm.
But I can use plus plus, and this will give me all the letters of the alphabet.
Interesting.
What would the output of this program be?
Infinite loop.
Okay, I agree it's an infinite loop, but what would the output be?
A. 2.
A, B, C, D, until like
Never.
how can you look at output? I mean the output.
You didn't give
If
it a.
it's infinite loop, how can you see
Well, it's going to write some output for a while.
that? Like
Yeah.
and stuff like
What's the output going to be?
16.
First time through, it's going to be an A,
A,
then a B, then a C, then a D, then an E, right?
yeah,
Is it gonna double in the A's? And
until 16.
Until it hits 65,535. Then what happens?
it starts
Stop.
over. No, it's gonna go to false, and then it's gonna hop out of the
Say
loop
errors and the memory like you can find.
Why would it go to false?
because then it wouldn't be true anymore that it's valid because it had passed the 65,535.
Yeah, but I'm not. I mean, this is a Boolean expression, isn't it?
Yeah.
And this will bring
Is
the
it
value-
possible for that Boolean expression to be false?
No.
By definition, that Boolean expression is true.
Yeah.
Mm-hmm.
In the purest form, that is a true Boolean expression, right?
Yeah.
So you're saying I'm going to start at 97 and I'm going to keep going all the way up to 65,535, and then what happens? What happens when I say 65,535 plus plus?
It's gonna stop
Why?
because you can't go past that in.
But
the
my
chart.
code says keep going.
I mean, there is
But it
It
another-
says go forever
Well,
while
then-
true.
Well, then it'll break.
there is another thing coming from the process of control. Stop. It's problem. You know,
But we just talked that the plus plus operator must work differently for chars.
there is something coming from.
It's a mystery.
Front end, like the programming.
Why must you do this to us?
All right, so
If you stop,
hold on. You think it's going to stop?
no. He's
What?
going to give an infinite loop until you get like message back. He said there's something wrong. Errors. And then
Okay, but what's going to happen after it hits whatever characters that it has Unicode value 65,535?
he's going to stop.
You think it's going to stop then?
He's not going to do anything.
But it's true. I just said the same thing, and he just yelled at me and kept saying it was true.
Yeah, this it will print the value of A and then stop. It will not go further.
No, but
You don't even think it'll print a B?
it's going to keep incrementing.
No, it's going to go until 16,500.
Yeah, like it will check and it is false. So it
Alright,
will
the
come out of
price
the loop.
isn't right anymore, so.
I'm just doing it this way because I haven't shown you anything else yet. So I'm going to print out the integer version of C. So that the first time through it should be 97, right?
Right.
Then I'm going to print out after that. I'm using print instead of println, so that does not press enter. So I'm just building kind of a line number followed by a space and a, what did I say, colon, followed by a space, followed by the character. So we can see it counting.
And then,
Okay?
then you got a print line.
Yeah, then I have my println that kicks it down a line. So we should see it getting close to 65,535. Okay, so we had one vote that says it's going to print out an A and then nothing happens. That's a stupid answer. Okay. Well-
Sensitivity train.
What's going to happen? That's fine, but what happens once it hits 65,535? The largest integer value that a char can hold is 65,535. It's a unsigned 16-bit integer.
It's gonna go right back down to 0.
Again.
You think it's going to go to 0?
Yeah.
Okay, and then do what?
And then go all the way up from 0 back to 65,535.
Why would it go to 0?
Because it can only hold from 0 to 65,535. So therefore, it's gonna keep going in that same loop forever.
There's no condition after the plus plus to stop that.
It's not valid. That's not valid
Right. But why would it go to 0?
because you can only hold values from 0 to 65.
So just magically it goes back to 0?
That's what the C++ is for. Boom. There you go.
but there's got to be a reason. All right, so let's see the behavior first. All right.
I gave you the reason.
Well, you haven't given me a good reason yet.
That was a very good reason. It was valid.
It's the wrong reason.
Yeah, sorry, it will just print the value of A until 65,000 times.
Okay, and then what?
Yeah, then it will come out of the loop.
You think it'll come out of the loop?
Yeah.
All right.
It will print A.
When does this loop end?
Yeah, the loop is getting true. Like it will take the value of C all the time, A all the time until the end.
Huh?
I think so. Yeah, it's keep.
Hold on. What am I doing right here?
Incrementing.
Yeah, you're incrementing, but still it will take the value of A.
Well, hold on. This is the Boolean expression of loop. What does that say? You got to actually read the code. What does our loop say? Our loop says keep looping as long as what is true?
Char.
Keep looping as long as true is true. That's like saying keep going until the moon, as long as the moon is the moon.
Well,
This is true. You will never break out of this loop. Ever. It's actually only a part truth.
Yeah.
Without some additional programmatic intervention that we don't know how to do yet, but I'll show you soon.
what, the red button to stop it?
No, there's some stuff.
Oh.
We got some stuff.
Infinite loop.
Okay, so we got the infinite loop, and you think it's gonna be an infinite loop? It's gonna zero back around?
Mm-hmm.
What do you think it's gonna zero?
No, it's not coming back to 0.
So what's it gonna do?
It will assign
It's
question
going-
mark all the time. So once it's
It's going to say question mark.
It's going to like, if in that processor is going to say, oh, there is a problem, happens in the process.
I already said it would be.
Well, so you think it'll crash?
Okay,
I
yeah.
already-
Okay, so you think at 65,536 it crashes. It's going to keep going until it gets to that, and then at that point it dies because it doesn't know what to do.
It's going to infinite loop in that crash.
I'm gonna let them know.
Yeah, but you're saying infinite loop.
Okay.
What's the output after 65,535?
Just keep printing out the arcade.
No, crash.
You think a crash? Okay, you think it'll just keep printing out 65, whatever the character is, the 65,535,
Yeah.
which very well might start being some question marks because this terminal in here might not be able to display some of the stuff.
Yeah, it will just,
But what I'm telling you is question marks are not errors. That's some character that this terminal doesn't know how to display.
Yeah.
It is a character.
Mhm.
Okay, so you think it's going to zero back around.
Yeah.
Just keep going.
Mhm.
You think it's going to crash. You think it's going to just stay on the final number. And
yeah, my answer after like once it's finished A, and then it will come to question marks. Yeah, until it's come out.
so why do you think it's going to say A a bunch of times?
No, sorry.
He
Yeah,
was
we are
stuttering.
implementing, so it will be A, B, C. So once it's finished, it will just assign the value like 65,000.
Okay.
Program.
Well, remember, I'm printing out line numbers here. So it should print out, the first time through it should be 97, then 98, then 99, then 100. So on your answer, when I get to line number 65,535, what happens on the next line?
Question mark. Yeah, it
What's
does
the
not-
next line number?
A.
Next line number, no, this is blank.
Oh, it just stops being a number?
Yeah,
So we got something that's not a number and a question mark.
yeah, like after 65,000, like Java does not know what the number should be assigned for that memory. Yes, it will assign the question mark with the blank space.
Yeah, but I'm getting an integer. Integers aren't question marks.
Yeah,
You
but
do a
still
good
like
job.
yeah, we are assigning the value of C.
Right. So I'm going to get the Unicode value of question mark.
Yeah.
Okay.
You do a good job at making us feel stupid.
No, just him. Are you confident with this?
Yeah, I think. Yes, I'm
He's-
confident.
Because I'm not confident with your answer, like at all.
No, like after 65,000, sir, like Java does not know for the character what the value should be assigned, so it will,
So why wouldn't it just have an error? Why wouldn't it like crash and say, okay, stop doing dumb things? Don't add 1 to 65,535.
yeah, but still like yeah, for a character you said like we can't assign the negative values, but still even if you assign minus 97,
Yep.
it will not show error. It will assign just question mark. It does not know. It will just.
Oh no, it definitely shows an error if you tried to say minus 97.
No, it will just come with question mark.
Not in Java. Java will be an error. You can't do the, if you try to make a negative 97 into a char, Java will not like that for one moment. It won't show a question mark. It'll die. It'll crash. All right, ready? Moment of truth?
Yes.
Just in case you didn't know, everybody who answered this question has just bet their final grade on the answer to this.
Absolutely.
We
not.
can't
I
all be right.
I recant.
I didn't bet a thing, so I'm good.
Alright, so there is a question.
No, remember, those are still characters. It just doesn't know how to display them. We already have the answer. We already have a big winner here in the front row.
Me?
You don't even know it's you yet.
Oh yeah, I do. Cause it keep repeating.
As soon as it gets to 65,535, what does it do?
Repeat.
Might not let me go up far enough to.
No.
It's definitely not. But as soon as it hit 65,535, it went back to 0. Went back to 0.
Boom. So I get an A, right?
You do?
Thank you
That was the deal.
for the class.
But
Boom.
I helped you.
what about
Right.
what about all these other unfortunate individuals?
You didn't say anything so awesome.
They failed.
Okay. So now let me show you the non-character version of this so we can kind of see this slower. So I'm going to say for byte B is equal to 0. B we'll just do it as a while true. Byte B is equal to 0 while true. System.out.println B B++. All right. What would the output of this be? What's a byte?
A byte is an unsigned,
It's gonna
no,
have
it's
the
a
maximum
sign.
number of byte and go back to 0.
Okay, what is that? Oh, not back to 0. What's a byte?
A signed whole number.
Byte is a signed 8-bit number, right?
Yep.
Negative 128 to positive 127.
Okay,
Correct.
to negative.
So we're going to go from 0 to 1 to 2 to 3 to 4 to 5, all the way up to 127.
And to minus.
And then it's going to go to minus
Minus
128. Minus 127, minus 126, all the way up to positive 127. Then it's going to go back to minus 128. So we'll see this. We'll see this go down here. Make sense? Okay. So now the question is why?
And you can like advanced for Java, but I believe
No, it would do the exact same thing in C or C++.
Because there is no condition to stop.
Oh, the condition is true.
Okay, here we will take Boolean expressions out of this. Then I'll ask you again.
It can only go in that one range. So whenever you add 1 to it, it's just going to keep going back in that range.
So B is 127. Print it out. Add 1 to it. Print it out. I get a negative 128. Why?
Because they can only go in that 8-bit range.
Well, that's true, but that doesn't explain why adding 1 to it goes back to negative 128.
It does, because it'll stay in that range. It can't go out.
I agree with that statement, but it doesn't explain mathematically why adding 1 to positive 127 becomes negative 128.
That is how it's expressed negative 128.
That's how what?
That's how it's expressed negative 100 minus 128.
Okay.
In bits.
Because the maximum number is 126.
In bits. Tell me about this. What do you mean in bits?
Like
How are numbers stored in a computer?
like 0110, like this kind of stuff.
Okay.
Yeah, that's how it's stored minus 128.
So an 8-bit number. I stopped counting there. That's an 8-bit number, right? One of those bits is used for the sign. Okay? So for right now, let's keep that at a 0. So we're positive numbers. We'll just say we're positive. Okay? This is the 1's place, the 2's place, 4's, 8's, 16's, 32, 64. This is 64 plus 32, which is 96, right? Plus 16. This is 127. Correct? All right, so this is 127. How do I add 1 to a binary number?
Right one. Yes, like this.
So I'm adding those two numbers together, right? This is the binary number 1, is it not?
Yeah.
0, 1, 1,
Okay. 1 plus 1 is what?
0.
1 plus 1 is 2.
Yeah.
Okay.
Binary.
1 plus 1 is 2. We can't hold 2. All right, so what do? We write a 0, and actually I'm going to need to just let me do that for right now. So we're going to write a 0, and we're going to carry the 1. So we have an extra 1 up here. 0 plus 1 plus 1 is what? It's 2. But we're going to carry the 1. We're going to write a 0, carry the 1. That's 2. Carry the 1. That's 2. Carry the 1. That's 2. So on and so forth until we finally get what?
1. That means minus.
Get a 1 there?
128.
Is that? Seems like we just went to a negative number.
Because it was positive with the 0.
So that's a negative number. The other 7 bits look like this right now. Actually, no, hold on. The other 7 bits look like this right now, right?
Correct.
That's the number we're looking at right now. Is that negative 128? But there's no bits there. What we're looking at right now, and he's right, he's absolutely right. What we're looking at right now is the reason why the negative number is 1 bigger, if you will, or 1 smaller than the positive version. So a byte is negative 128 to positive 127. It's because of what we're looking at right here. The transition. The point when we finally go negative, the biggest negative number that can be represented in binary is a whole bunch of zeros followed by the 1 in the sign box, sign place. We know that we can't hold a number bigger than 127 in 7 bits.
Right.
We can't represent it. So this is our special case. This is the case where if we had no bits, that is the 128. And that situation only exists when our sign is negative. Does that make sense? So the reason why it goes up, goes to the negative side, is because when we add 1, it turns into this, which is negative 128. If we add 1 to this,
Negative 1.
why?
Because you're adding 1.
No, I agree, but that doesn't look like negative 127 to me.
It's negative.
That looks like negative 1 to me.
Yeah, but you still have like negative 128.
Well, hold on. Let's go back here. Is this guy going to print out negative 127 or is going to print out negative 1?
127.
Negative
127. Well, negative 127, right? But it looks like that. What number is this?
It's
It's 1.
negative minus 1, 27.
So why do we read it this way?
Because we
How do we identify, how is the computer, I mean, it is. The computer's reading this as a negative 127, clearly. We just showed it, right? Why does the computer see this as a negative 127 and this as a negative 128?
I think
because
just
it
don't
has
find
a
it.
like positive value. Because unsigned, because that means the left 1.
This is the ones place, right?
Okay.
Ones, twos, fours, eights,
6.
16s, 32s, 64s, 128. This is the 128th place.
It's minus 128.
Okay? When I have a 1 here, I know that I am negative. We're using that as a sign place. If I put a 1 there,
Because minus 128 plus 1.
Right.
That's minus 1.
that's it. Negative 128 plus the number that's represented in my 7 bits gives me negative 127. So negative 128 plus a positive 1 is negative 127. Make sense?
Yeah.
So the reason it's working this way, the reason the integers wrap, is because this is how binary math works. And computers love that. Computers do binary math. That's their thing. Make sense? Okay, so something to keep in mind, and this will work in any programming language, because that's how computers do math. It's not a language-dependent thing. It's a computer math coprocessor thing. All right. Make sense? All that crap?
Does the same thing happen with the character type and with the chip? Like when the
Yeah,
number to zero,
we saw it. It
zero.
went from 0 to 65,535 back to 0.
Okay, but when doing the binary, it's going to line 0 plus 1.
No, it doesn't have to do the negative numbers.
Okay.
So I understand what you're saying. It would be this, and I really don't want to do the math, but just deal with me. So biggest number be, that's 65,535. That's what that number is. Okay, if I add 1 to that number, what happens? If I add 1 to that number, that's, sorry. Why can't I hold down a key? This just seems stupid. All right, so 1 plus 1 is 2, so that's 0, carry the 1, 0, carry the 1, 0, carry the 1, blah, 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 all the way back here to the beginning. We have another carry right here, so we have 1 plus 1 is 2, carry the 1, that's an overflow bit. So we lose it. Because we carried it to a spot that's not there. It's called overflow.
Okay, we get the 0.
So the answer is this.
Okay, we get this 0's number. And we have C++. And that means C equals C plus 1.
Correct.
And the 1 is like get 1.
Right, but understand that a char is a character representation of an unsigned integer.
Okay. That means 0's.
So if we if we strip away the char part of it, and we just deal with the math side of it. Once we hit the number 65,535 and we add 1 to that, 65,135 or 65,535 is 16 bits, all ones. And as soon as I add 1 to that, I get 16 bits, all zeros.
Okay. If I change the statement, I said C equals C plus 1. It's going to be doing like rules 0 and 6.
No, it actually fails then because of how it's resolved. So you're saying if we say C is equal to C plus 1, this fails because C is a char. And when it resolves, it'll resolve to a char. So we're actually resolving that to its value, which is a char. So let's just say it's an A.
That's why they can.
Yep. So the plus plus operator internally does the mathematical increment and then casts it. So my feeling is what it does is it probably, the plus plus operator for chars is probably implemented in terms of shorts that can't go negative. That would be my guess. So it's probably a, if we kind of write that, let's say short s is equal to 0. While true, system.out.println s plus plus, like that, right? But now when s hits 32,768, which is the maximum positive number for a short, it will go to negative 32,760. Actually, when it hits 32,767, it'll go to the maximum negative value of negative 32,768. So what we'll do is ask a little question here. If s is less than 0, set s to 0. So my guess is that the code for incrementing, whoever wrote the increment procedure for chars, it probably is something along these lines. They probably wrote it in terms of shorts. That make sense? They may have written it in terms of chars, or I'm sorry, in terms of ints and limited it to the 65,535 as the top shelf and 0 is the bottom. So they would have two if statements in there under those circumstances. And you might say right off the bat, well, that seems kind of inefficient. Well, chars in and of themselves are inefficient. They're stored in the most efficient way that for a computer, they're stored as numbers. But the reality is under the hood, we're constantly doing mappings. Give me the Unicode character version of this number. You're constantly looking it up and translating it. So it's a low performance, in the big scheme of things, low performance thing anyways. Okay, questions about that? All right, so let's take a 10-minute break. That'll take us to 8:05, and we'll come back and I want to talk about the character class, and I also want to talk about strings. Okay, so 8:05.